ILP is instrumental in what I do. They're instrumental in helping me to both establish new connections with specific companies, to figure out strategically how to engage with a broad sector of the industry, but also to continue to amplify the collaborations that we do have. The relationships that I have with Amazon or with Apple or with Shell are but one relationship that those companies have. And ILP can help foster and understand those broad set of connections that many investigators, many programs across campus have into the many people at any one company. It really helps us to manage and augment the network and identifying opportunities that we may have missed without their assistance. My group and my interests span from mechanical engineering to computer science to optical engineering to electrical engineering. I'm a mechanical engineer, computer scientist. I have expertise in mechanical engineering and I have expertise in computer science. So that allows me to be innovative in the intersections of those spaces, to bring together adjacent, seemingly disparate domains in addressing challenges in medical imaging, to address challenges in manufacturing. My definition of innovation, and the definition I try to convey to my students, is if you want to have impact in today's world, you can't just be expert in one area. You need to be expert in at least two areas, and to have the ability to speak the language that brings those communities together. Real innovation, in my opinion, happens when you're now bringing topics and ideas and solutions from different fields together. That's where modern innovation happens. And then translating that intersection of fields into new knowledge, into a new product, but it's bringing together those sometimes seemingly disparate fields is, for me, the nexus of what innovation is. Several years ago, Arconic, formerly known as Alcoa, reached out to MIT to ask us to develop a program in smart manufacturing. And by my definition, that they agree with, smart manufacturing is the proliferation of information technology in the manufacturing enterprise. Professional education is a very different beast than the education that we will do on campus. For this program, we designed with Arconic. We brought in 40 plant managers from around the world. And for a 2-week experience, first 1 week in September and then 1 week in January, exposed to them the fundamentals of everything from sensors to feedback control to statistical process control to the simulation of factories to logistics and supply chain. And between those 2 1-week sessions, worked with those plant managers to identify opportunities within their individual facilities to apply what they were hearing from us. And then in addition to executing on projects in their environments, at their facilities, we also developed, in collaboration with several of my students, David Kim, Lauren Chai as examples, a tabletop manufacturing system, a smart fiber extrusion system that allows us on a bench scale to make a very precise strand of fiber, to start with an input material or a raw stock polymer and end up with a wound spool of thread. But that system now is a real tangible thing that we can bring into the classroom. That's at a low cost enough that we can make 6 or 7 of them and have teams of these plant managers looking at the sensors, doing experiments, modifying the set points for the controller. And instead of having a classroom experience that's away from their plant and away from real manufacturing, that we bring the manufacturing into the classroom and to have an educational kit that is not extremely dissimilar from the things that they would see in their own plants.